Good morning students. In 2B class the first topic is circles and it has a weightage of 22 marks in IPE exams. You will get two 7 marks questions and one 4 marks question and two 2 marks question. So the total is 14 plus 4 plus 4 is 22 marks. Very important topic. Now let us see the definition of the circle. The definition of the circle. The set of all points. The set of all points which are at a constant distance. Constant distance from a fixed point. From a fixed point form a circle. Very easy to understand. The set of all points which are equidistant or at a constant distance from a fixed point form a circle. Now see this. Now let fixed point be C. Let C be the fixed point and the constant distance is smaller. Now the set of all points which are at a constant distance from this fixed point. So these are all the points which are at a constant distance from the fixed point. Those all points form a circle. Very easy to understand. The points which are at a constant distance from the fixed point form a circle. Now the fixed point is called center. That fixed point is called center of the circle. This one, where we have fixed one point denoted with C, is called center of the circle. And the constant distance is called radius. The constant distance is called radius of the circle. Fixed point is called center and constant distance is called radius of the circle. Equation of the circle with center CH comma K, center CH comma K and radius R is x minus h whole square plus y minus k whole square is equal to r square. Very important concept. Let us prove this theorem. Now let CH comma K be the center. And R be the radius. R be the radius of the required circle. Now let us draw a circle with the center CH comma K and the radius small r. Now, by the definition of the circle, any point lies on the circle is at a constant distance from the fixed point. So, every point that is on the circle is at a distance radius small r. So, let Px comma y be any point on the circle. So, let Px comma y be any point on the circle. Now by the definition of the circle, every point on that circle has to satisfy a certain condition that it should be at a distance r from the radius. So that you can say that Cp is equal to small r. Cp is a geometric condition. Cp is equal to r is a geometric condition. You need to convert that geometric condition into algebraic condition. Now what is Cp? It is the distance between center and two points which are ch comma k and px comma y. Now you know how to find the distance between two points. Distance between two points is root over x2 minus x1 whole square plus y2 minus y1 whole square. So that will be root over x minus h whole square plus y minus k whole square is equal to r. Now if you take squaring on both sides, it will be x minus h whole square plus y minus k whole square is equal to r square, which is our required circle. So it is the circle with the center h comma k and radius small r. Very important concept. Now if a circle has radius 1 unit, then that circle is called a unit circle. Remember this point. If a circle has only radius 1 unit, then it is called a unit circle. If a circle has radius 0, there will be, you can see more examples in problems. There will be circles with radius 0. Every point in the geometric plane is a 0 radius circle. Remember that. So a circle with radius 0 is called a 0 circle or point circle. Now let us see another point. A circle with the center 0, 0 and radius r. Now we have seen the circle with the center h, k. Now what will happen if the center of the circle is 0, 0 and radius r is x square plus y square is equal to r square. The equation of the circle with the center 0, 0 and radius r is x square plus y square is equal to r square. Simply you can write 0, 0 in place of h, k in previous theorem. The equation x square plus y square plus 2gx plus 2fy plus c is equal to 0 represents a circle with a center minus g comma minus f and the radius small r is equal to root over g square plus f square minus b. Very important theorem. Thus equation x square plus y square plus 2gx plus 2fy plus c is equal 0 represents a circle with the center minus g comma minus f and radius r is given like this. Now we have to show that this equation represents a circle. Let us consider this equation. X square plus y square plus 2gx plus 2fy plus c is equal to 0. We have to show that it is a circle equation. Now we know how the equation of circles looks like. It will be of the form x minus h whole square plus y minus k whole square is equal to r square. So let us convert this equation into that form. X square plus 2gx plus y square plus 2fy is equal to minus c. Now I am adding g square plus f square on both sides. X square plus 2gx plus g square plus y square plus 2fy plus f square is equal to g square plus f square minus c. I have added g square plus f square on both sides. There will be no change. Now x square plus 2gx plus g square can be written as x plus g whole square y square plus 2fy plus f square can be written as y plus f whole square is equal to g square plus f square minus c. Now you can rewrite like this: x minus of minus g whole square plus y minus of minus f whole square is equal to root over g square plus f square minus c whole square. Now clearly you can see it is in the form x minus h whole square plus y minus k whole square is equal to r square. Therefore, it is a circle with the center. What is the center of the circle? Minus g comma minus f, and the radius r is equal to root of g square plus f square minus c. So, this equation represents a circle with the center minus g comma minus f and radius root over g square plus f square minus c. Equation x square plus y square plus 2gx plus 2fy plus c is equal 0 is called the general form of the circle. Very important. These are going to be very important points. So that equation x square plus y square plus 2gx plus 2fy plus c is equal to 0 is called general form of a circle. General form of a circle. So this is the general form of the circle. Now this equation looks like a second degree equation. It is a non-homogeneous second degree equation. You have a non-homogeneous second degree equation in first year pair of straight lines. Now, an equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 is called a second degree non-homogeneous equation. Now you can compare these two equations. When you compare these two equations, here the xy coefficient is 0 and the coefficient of x square and y square are always equal. Now there is a theorem, we are not going to prove that theorem. So a second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represents a circle A. Now it represents a circle A. The first point is A is equal to B. Very important point. That means coefficient of x square and coefficient of y square must be the same number. And h is equal to 0. The third point is g square plus x square minus ac greater than or equal to 0. This is very important concept. A second degree non-homogeneous equation represents a circle if a is equal to b, h is equal to 0 and g square plus f square minus ac greater than or equal to 0. Another form of a circle. We know that the diameter subtends right angle at any point on the circle. We know that concept in even first year vector algebra, and you should have learned in 10th class also. Diameter subtends right angle at any point on the circumference of the circle. So the theorem says that the equation of the circle with ax1 comma y1 dx2 comma y2 as the extremities of diameter is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. This is the theorem. Equation of the circle with the ax1 y1 bx2 y2 as the extremities of the diameter. Now let us see. So you know what is the definition of diameter? Diameter is the largest part, or diameter is the line segment passing through the center of the circle. So diameter bisects the circle. So diameter bisects the circumference of the circle. Now let ax1 y1 and bx2 y2 are the extremities of the diameter. So and P be any point on the circumference of the circle. Px comma y be any point on the circumference of the circle. We know that the diameter subtends right angle at P at any point, so that it subtends right angle at P. It subtends right angle at the point P on the circle. So we have angle APB is equal to 90 degrees. That means these two lines are perpendicular. PA is perpendicular to PB. It implies PA is perpendicular to PB. If two lines are perpendicular, then product of their slopes is -1. We know that concept. Now product of slopes, that means m1 into m2 is equal to -1. Consider the slopes of PA and PB. So slope of PA is y minus y1 by x minus x1. You know the slope of the line joining two points, y2 minus y1 by x2 minus x1. Slope of PB is y minus y2 by x minus x2 is equal to -1. So that y minus y1 into y minus y2 is equal to minus of x minus x1 into x minus x2. Now take the term on the left side. You will get x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0, which is the equation of circle having ax1 y1 and bx2 y2 as the extremities of the diameter.